In this lesson, you will learn how to use law of sines to solve triangles. In previous lessons, you have learned the trig ratios sine, cosine, and tangent. Those trig ratios can be used to solve for missing sides or missing angles in only right triangles. The law of sines can be used for missing sides and missing angles of any triangle. It does not have to specifically be a right triangle. So the law of sines says if you take sine of an angle, so angle A here, and divide it by its opposite side, so side little a, it is proportional to the sine of angle B, a different angle of the triangle, and its opposite side, little b, which it would also be proportional to the third angle and third side. So sine of an angle divided by its opposite side is going to be equal to or proportional to another angle divided by its side. So let's look at our first example. We're going to find the measure of BA. So here is side BA. Nope. Here is side BA. So we're going to be solving for this missing side. Notice in order for law of sines to work, you're going to have to be given an angle and its opposite side. Otherwise, we don't have enough given information to set up the problem. So we're given angle B, so we'll say sine of 28, and we're going to divide it by its opposite side. You need to know at least one whole fraction or one whole ratio in order to solve this with law of sines. So then we're going to take, because we're trying to find side BA, which we're going to just call that little c when we're solving, we can set it up sine of 42 over the side that we need to solve for. So now we use cross multiplication to solve this proportion. We have c sine of 28 and 8 sine of 42. You will then need to divide by sine of 28. So we will find that c is going to equal to the 8 times sine of 42 over sine of 28. Let's punch this in the calculator now. Of course, before using the calculator, always make sure that you're in the correct mode. So go to the mode key, arrow down until you're on the radians and degrees, and make sure you change it to degrees. All of our angles are in degree measures, so that's the mode that our calculator needs to be in. So we'll type in exactly what we say c equals, which is 8 sine of 42. It may be best to do alpha y equals to get your fraction. So you can do 8 sine of 42, and we're going to divide that by sine of 28. We'll round it to the nearest tenth since it's a side of the triangle. We have 11.4. So side AB, or BA, either way you want to call it, BA is 11.4, and we solved that using the law of sines. Let's look at example 2. Now we're trying to find angle C here. Well, notice we do know the opposite side from angle C, so that is helpful. And then we need to find a pair of angle sides that are opposite one another. We have angle B that is opposite of this AC, so that will work for setting up and solving sine by the law of sines. So let's start with our angle B, sine of the angle divided by its opposite side is going to equal sine of the angle. So this time we're trying to find C over the opposite side. So again, let's cross multiply now that we have our proportion. 15 sine of 33 And it is best to write it this way. If you write sine of 33 times 15, sometimes we accidentally type that inside of the sine parentheses when the 15 is not part of that. So 15 sine of 33 will keep you from messing up your work. 12 sine of C. We need to divide both sides by 12. So notice here we have 15 sine of 33 over 12, which equals sine of C. The problem here is we're trying to find angle C. So remember in previous lessons, in order to find an angle, you have to use inverse sine. You can see that if we took the inverse sine of both sides, here we will type in inverse sine of all of this part, and inverse sine and sine cancel one another out, leaving us with just our angle that we need to solve for. So let's do that in the calculator. Of course, we've already checked our mode. It is in degrees. So we're going to do inverse sine. So second, the blue second key, second sine will get you inverse sine, and do alpha y equals to get your fraction. Just choose that first option. So we'll do 15 sine of 33, and this is where it's important to put that 15 first so you don't accidentally put it inside with the sine of 33. 15 times sine of 33 over 12. All of that, if we round it to nearest whole degree, makes it 43 degrees. So angle C equals 43 degrees. So let's look at example 3. Here we're going to find the side QR. So QR is what we're going to find. You can let that stand for X or maybe little p. I'm going to go ahead and let it stand for X, since sometimes little p can still get confused as big P. Well, notice here we don't quite have enough information. We don't have the angle that's opposite of that side. So we've got two unknown values here. It's going to be difficult to solve with law of sines by just going straight to solving for QR. But let's see if we can solve for something else to lead us up to get to QR. We do have an angle and its opposite side, so we can still use law of sines because we've got these pieces here. Notice that we have the side that's opposite angle R. So if we can solve for angle R, we can use the angle sum theorem because all the angles of a triangle equal 180 degrees. So once we know angle R, we'll be able to find angle P, which then will give us the opportunity to set up that ratio. So let's walk through this. We've got angle Q, so we'll say sine of 39. We're going to divide that by the opposite side, 28. We're not going to solve for QR just yet. Like we said, we don't have enough information. That's a missing piece, and the opposite angle is a missing piece. But we can solve for angle R. So let's set up angle R with its opposite side. So sine of R with its opposite side of 41. So let's cross multiply. We get 41 sine of 39. It's going to equal 28 sine of R. To solve, we divide by 28. So notice we have sine of R, which would really mean we need to do inverse sine. So we're going to type in inverse sine of all of that 41 sine of 39 over 28. And that will give us the measure of angle R. So let's do that. So inverse sine, do second sine, alpha y equals to get your fraction. Have 41 sine of 39. And then the denominator, we're going to divide by 28. Check and make sure everything's typed in correctly. We're good. So that gives us a measure of 67 degrees. So angle R Round the nearest whole degrees is 67 degrees. We're not going to stop there. We weren't asked to find angle R, although we needed it in order to move further. Once we know 67 degrees for angle R, we can find angle P. So if we take 180 degrees and subtract the 39 that we started with, then also subtract the 67 we just found, that will give us the measure of angle P. So 180 minus 39 minus 67, that gives us 74 degrees for angle P. That's by the angle sum theorem. All three angles of a triangle add to 180 degrees. So if you know two of them, you can subtract them from the 180 to get your missing angle. So here we have 74 degrees for angle P. So we now have enough information to solve for our missing side that we asked for, QR. Notice we still have the angle and the side opposite one another. You could use what originally was given or the one that you found. I prefer doing the one that originally was given just so that if I've made any mistakes, although this problem, one mistake would lead to the next, so even if we messed up 67, that would mean that 74 is wrong because we had to use it here, but I just tend to try to go with what was always given. So I'm going to still set up the sine of 39 over the 28. Again, you could have done sine of 67 over the 41. It would still work. It may not come out exact, but because we're rounding, they will come out fairly close. So sine of 39 over 28, because we're trying to find QR, we're going to come here to this angle, 74 degrees, divided by our x. So sine of 74 and divide it by our x. Cross multiply here, so we have x sine of 39 equals 28 sine of 74. We're going to divide by sine of 39 on both sides. Notice once we divide, we have x, or what we're trying to find is QR, by itself. We will not need to use inverse sine. We are not solving for an angle on this problem. We're just ready to type that into our calculator. So let's see. We've got 28, let's do our alpha y equals 28 sine of 74. We're going to divide that by sine of 39. Rounded to the nearest tenths, we get 42.8. So side QR that we were asked for, this is our final answer, is 42.8.